Yes, good evening everyone. Please turn on your videos. Fine. So now let us start with the chapter that is similarity. Now, what are similar and what is the difference between similarity and a congruent? Okay, first let us understand what is similarity, what is the difference between similarity and a congruency. Suppose if I am drawing this kind of rectangle, okay, and this is one rectangle and this is another rectangle, I have enlarged this rectangle to some extent. Okay, what about these two triangles? These two triangles are congruent or similar? These two triangles are similar because they both are same shaped. They both have same shape, but the size of both of them are different. In similarity, what happens? In similarity, what happens? Size differs, but shape is same. Shape is what? Same. In similarity. Over here, these two triangles have the same shape. Yes or no? The two things will be said as similar when they both have same shape, right? But they are not of shape same size. Fine, these two triangles are similar. Okay. Also, why they are similar? What is the properties of that when the two triangles are similar? See, if I take this triangle and if I take this triangle on it, what happens? This angle and this angle are same. If I take the upper angle, that angle is also same. And if I take this angle, that angle is also same. Then what is different? Only the sides are different, but the angles are always same. What happens in a similar triangle? In the similar triangle, all the corresponding angles will be equal. Means that is this angle will be equal to this angle will be equal to this angle, and this angle will be equal to this angle. What happens in the two similar figures? If you are taking two similar triangles, what will happen? All the angles will be equal, but all the sides will not be equal, but they will be in all the, if you take the ratios of all the sides, they will be equal. See, if I say if this is ABC and this is PQR, okay, if I say this is ABC and PQR, if these two triangles are similar, if triangle ABC is similar to triangle PQR, then what will happen? That is AB upon PQ, the ratio of this side upon this side, will be equal to this side upon this side, that is AC upon PR, will be equal to this side upon this side, that is BC upon QR. Understood? Their distances will not be equal, but if you take the ratios of their corresponding distances, they will be equal. Understood what is similar triangles? When the two triangles will be said as congruent? When the two triangles will be said as congruent? See, if I take this triangle and if I take another triangle over here, these two triangles are congruent to each other. Why they are congruent? Because if I take one triangle and try to place it on the other triangle, it exactly fits on the other triangle. Got it? It exactly fits on the other triangle. That's why what I can say, these two triangles are what? Congruent. If I say this, if I say this as my triangle PQR, then in this case, triangle ABC will be congruent. The congruency is given by this sign, will be given as congruent to triangle PQR. And when they are similar, we write it like this. One this S type, which is horizontal. When they are similar, we write like this, and when they are congruent, we write it like this. Is that clear? What is congruency? When the shape and size both are same. And what is similarity? When the size is different, but the shape is same. Got it?
Yes, sir.
Yeah, fine. Now we'll do some exercises based on this. Yeah. And when the two triangles will be similar, first let us also understand when the two triangles will be said as similar. When at least two angles are equal, then also we can say that the third angle will be equal. Why the third angle will be equal? If I say, if I draw these two triangles like this, if I am drawing two triangles like this is one triangle. No, no, not by Pythagoras. No, no, not by Pythagoras.
Because all sides of a triangle add up to 180.
Yes, that's what. Now see over here, if I say these are the two triangles, okay, this is let's say this is A, this is B, and this is C, okay, and this is P, this is Q, and R, and I say that this angle is equal to this angle, and the other thing which I say is this angle is equal to this angle. If I get that if the two angles are equal, the third angle has to be equal. Why it has to be equal? Because see, if this is 30, consider if this is 30 and this is 50, not 50, let's say this is 90, then this has to be 60. Why? Because this, it means all the angles will should add up to 180. If this is 30 and this is 90, this has to be 60. Also, if this is 30 and this is 90, this also has to be 60. The third angle will be equal only. If two angles are equal, the third angle has to be equal. Why? Because all the angles add up to 180 degree in a triangle. So what is the requirement? That the two triangles are similar. If you get that, if any two pair of angles are equal, then what we can say that the two triangles are similar. Understood? Is that clear?
Yes, sir.
When we will say that the two triangles are similar, when we get that if two angles of a triangle are equal of two different triangles, then what we can say that the two triangles are similar. And once the two triangles are similar, then what we can say over here, triangle ABC is similar to triangle PQR. So what we can say, angle A will be equal to angle P, angle B will be equal to angle Q, and angle C will be should be equal to angle R. Fine. Also, if I want to write the ratios of their sides, I write AB upon PQ like this. Then it should be equal to BC upon QR, and then it should be equal to AC upon PR. Understood how to write? The sequence of writing the triangle's name is very much important in similarity of triangles and also in the congruency of triangles. If you write ABC, you cannot write it as QPR. If you write that triangle ABC is similar to triangle QPR, okay, QRP, suppose, then it will be wrong. Why it is wrong? It is wrong.
Because the order of the angles is wrong.
Yes, because
The
over
side.
here A is not equal to Q. A is equal to P actually, right? This angle is equal to this angle, no? So where if I write A over here, it should be P only. If I write B, B is equal to Q, no? So over here it should be Q. Understood why I have said this as wrong? Is that clear? Pahal and Vriti.
Yes, sir.
Yeah, Pahal, is that clear? Clear? Okay, fine. Now let us start with the exercise. Now I think we can start with the exercise. Let us start. So this is what the exercise which you have. Okay. Now if I say, if I take these two triangles, what you have to find in this? Find the sides marked with letters in the question 1 to 11. All lengths are given in centimeters. Fine. You have to write the lengths of the letter. Fine. If I take the question number 1, now what they are equal, which two triangles are similar? The two triangles are similar. Obviously they are not congruent. Why? Because if I place one triangle on the other triangle, it will not overlap completely. Yes or no? It will be overlapped completely, or it will not be overlapped.
Will not be overlap.
Yes, it will not be overlapped completely. Right? So what I can say over here, angle B is equal to angle E, angle C is equal to angle F. That means angle A is equal to angle D. So what I can say, triangle ABC what I can say, triangle ABC will be similar to which triangle?
DEF.
Perfect. Right? The two triangles are similar by what? By AA test of similarity. Angle test of similarity. Yeah, angle test. Why? Because if two angles are equal, we can say that the two triangles are similar. And which two angles were equal? If you want to write that also, you can write that. Angle ABC is equals to angle DEF. Angle BCA is equal to angle EFD. Now, if two angles are equal, then what we can say that the two triangles are similar by AA test of similarity. Now, if the two triangles are similar, then what we know? Then the ratio of the corresponding sides are equal. That then what I can say, AB upon DE will be equal to BC upon EF will be equal to AC upon DF. Is that clear? Now, what are values they have given? For AB, they have given that as small a, fine. For DE, they have given it as 5 units. For DE, they have given it as 5 units, 5 centimeter, you can say. BC, what is BC? BC is E centimeters. EF, EF is 6 centimeters. AC, 2 centimeters. And DF, 4 centimeters. Got it? Now, if you take these two equations, if you take these two, then what you get? E upon 6 is equal to 2 upon 4. So E will be equal to 2 upon 4 into 6. 2 3s are, 2 2s are, 2 2 1s are. So answer is the value of E is 3. Fine. Also, if you take this two equation now, A upon 5 is equals to E upon 6 or A upon 5 equals 2 upon 4. You can take any one. So if I take A upon 5 equals 2 upon 4, so what I get? The value of A as 2 upon 4 into 5. 2 5s are, you can cancel. So 5 upon 2, 5 upon 2 is 2.5. So the value of A is 2.5 centimeter and the value of E is 3 centimeter. Is that clear? That means the value of A is how much? 2 centimeter. And the value of, sorry, it is 2.5 centimeter. And the value of E is 3 centimeter. Is that clear?
Yes, sir.
Yeah, fine. Now we can start with the next thing. That is question number 2. So I will ask you to solve. Try solving question number 4 on your own. Tell me what is the values of M, A. Can you do it? Please try and tell me
Yes.
what is the values of M and A.
One second.
Okay. M is how much?
I got M as 10. I got M as 10.
Yeah, the value of M is 10. That's right. The value
I'm
of,
actually calculating the A value.
okay.
So can you explain again how to solve? Because I wasn't.
Yeah, I will explain. Yeah. Now how to solve? See these two triangles. First of all, this angle L and angle A is equal. They have given. Over here they have given 2 dash and over here they have given 2 dash. That means this angle is equal to this angle. If two angles of a triangle, two different triangles are equal, then what we can say that the two triangles are similar. Fine. What we can say that triangle LMN is similar to triangle ABC. That means they are of same shape but not of same size. Now if two triangles are similar, then what we can say that their corresponding sides are equal. The ratio of the corresponding sides are equal. That is LM upon AB should be equal to mn upon bc should be equal to ln upon ac. Fine. After that, you can write the values whatever you have. What is the value of lm? The value of lm is m. The value of ab is 6. The value of mn is 15. The value of bc is 9. The value of ln is a. And the value of ac is m. So if I want to find what is the value of
Sir,
a and m, what I will do, if I use only this much, I can get the value of
sir,
m. Yes.
the value of M is 10 and A is 18.
The value of a is not 18. The value of m is 10. That is right. See over here.
Eight. I got the value of A. I got 16.6 recurring.
Yeah, that's right. So if you want to find the value of m, you can use these two equations. So m upon 6 is equals to 15 upon 9. So this 6 can go on the right hand side. So m will be equal to 15 into 6 by 9. 6, 3, fine. Now over here, what we was doing, we was calculating the values of m. So over here, 3 2s are, 3 3s are, then 3 5s are. So 2 5s are 10. So the value of m is 10. Once you get the value of m is 10, now you can use these two values to get the value of a. So now 15 upon 9 will be equal to a upon m. The value of m we got is 10, so you can put that value. So 15 upon 9 will be equal to a upon 10. So the value of a will be equal to 15 into 10 upon 9. 3 3s are, 3 5s are, 5 10s are 50. So answer of a is 50. What do you get? 50 upon 3. You can write this. Is that clear? Yeah, even if you write in fraction, no problem. So over here we got the values
Okay.
of a and m. Clear, no? Yeah?
Yes, sir.
Okay, fine. Now the next sum. Over here, see, when the two lines are parallel, when the two lines are parallel, yeah, when the two lines are parallel, and if I draw any transverse to this line, if I am drawing any transverse to these two parallel lines, that is, what are parallel lines? First tell me, what are parallel lines?
The lines which never meet each other.
The lines, what?
Which the lines which never meet each other.
Yes, the lines which never meet each other, they are parallel lines. Perfect. That's right. So over here, these two lines are parallel, right? They are never going to meet each other, right? If I draw any transverse to this, what will be the relation between this angle and this angle? Can you please tell?
Corresponding
Yes,
angles.
they are equal and they will be said as corresponding angles are equal. Fine. Also, what will be the relation of, say, this angle and this angle?
Vertically opposite angles.
Perfect. And they will be equal or not?
Equal. Yeah.
Yes, they will be equal. Okay. What will be the relation of this angle and this angle?
Corresponding angles.
Again, it is
Corresponding.
corresponding angles and they both will be equal. Fine. Now, similarly, over here, the triangle which they have given, over here they are saying this and BE and CD both are equal. Say both are parallel. See, whenever they are drawing arrows like this, what does it mean?
The lines are parallel.
Perfect. The lines are parallel. Now, if these two lines are parallel and if I draw this as the transverse, then what about this angle and this angle?
Corresponding angles.
They both are corresponding angles and they both will be equal. So what I can say in triangle ACD and triangle ABE, right? What I can say in triangle ACD and triangle ABE, what I can say angle ABE, angle ACD is equal to angle ABE. Why? Corresponding angles. They are corresponding angles. Why they are equal? Because they are corresponding angles. Also, this angle will be equal to this angle. Why? Because these two lines are parallel. And if I draw any transverse, then these two angles will be corresponding angles. No? Again, what I can say, angle ADC is equal to angle AEB. Why? The reason is again the same, corresponding angles. Yeah. Now, if the two angles are equal, then what we can say about the two triangles? What I can say about these two triangles?
So for the
That they are
smaller triangle,
similar.
P plus P
Yes,
would be
that the two triangles are similar. The third angle is also common, and what we can say that the two triangles are similar. If two angles are equal, what we can say that the triangle ACD is similar to triangle ABE by which test? By AA test of similarity. That is, we have proved that two angles of this triangle are equal, then what we can say that the two triangles are similar. Now, if the two triangles are similar, then what we can say? Their corresponding ratios are equal. That is, AC upon AB will be equal to CD upon BE will be equal to AD upon AE. Yes or no? Yeah. That is AC
Yes.
upon AB is equals to CD upon BE is equals to AD upon AE. Yeah. Now keep the values. Take this triangle, whatever they have given. We'll take this triangle and keep these values in it. What is the value of AC? AC is 6 plus Y. Yeah. What is the value of AB? That is only Y.
Y.
What is the value of CD? That is X. What is the value of BE? Y minus 1. What is the value of AD? 6 plus 4, that is 10. And what is the value of AE? That is 6. Now I have to equate one of them to get the values of X and Y. Can I equate? I should equate this two or I should equate this two. Which one I should do?
6 plus y upon y into 10 by 6.
Why? Why but I have to do this? Why not this?
Because there are two variables in the second one.
Perfect, perfect. Very good. If I equate this two, then there will be two unknowns. One equation and two unknown cannot be solved. We cannot get the unknown, right? And if I equate this and this, one equation and one known, I can find the unknown, right? So what I can do, 6 plus y upon y will equate with 10 upon 6. Fine. First we will simplify. 6 plus y upon y will be equal to 5 upon 3, cancelled in the table of 2. Then you can do the cross multiplication. 3 into 6 plus y will be equal to 5y. 18 plus 3y will be equal to 5y. 3y goes on that side. 18 will be equal to 5y minus 3y. 5y minus 3y is 2y is equals to 18. So y equals 18 upon 2. So what will
9.
be your answer?
9.
I got the value of y as 9. Now what I will do? I will take this as the equation now to get the value of x. Yeah. What I will do? I'll take these two values to get the value of x because I can now, my unknown is only x, not y because y is already known. So x upon 9 minus 1 will be equal to 10 upon, will be equal to 5 upon 3. 9 minus 1 is 4. Sorry, 9 minus 1 is 8. So x will be equal to 5 into 8 by 3. 5 eights are 40. So x will be equal to 40 by 3. You can keep it in fraction also in terms of decimal. So x will be equal to 3 ones are 3, 3 threes are 9 point, and then it is just not non-terminating 13.3333 and it will just go on. Got it? The values of x and the value of y both are known. Is that clear? The whole sum is clear to you? To solve this fifth question, not fifth. If I ask you to solve, yeah, the sixth question, can you solve? Get the values of x, y, x and w. Can you do it?
Yes.
Please do
Yes.
it. Please do it. And tell me what are the values of y and w and x. See in this, these two lines are parallel. Then this angle is equal to this angle. And this angle is equal to this angle. That's sufficient that the two triangles are similar, right? What I can say, triangle ABE is similar to triangle ACD, right? Once these two triangles are similar, I have to write with a proper sequence. A is equal to A, B is equal to C, and E is equal to D. Now what I can say, that is AB upon AC will be equal to BE upon CD will be equal to AE upon AD. Fine. After that, what is the value of AB? That is 3. What is the value of AC? That is 3 plus W.
So
Yeah.
I've written vice versa. Like I've written AC upon AB equal to CD upon BE.
No problem. No problem. It does not matter. The answers will be same. You'll get the same answers. Yeah. So 3 upon 3 plus W. BE. That is BE is 4 and CD is 6. AE is X and AD is X plus 2.
X plus 2.
So you can take this as the first equation to get the answer of W. So 3 upon 3 plus W is equals to 4 upon 6. You can take this as the equation. First we will simplify. 3 upon 3 plus W will be equal to 2 upon 3. Then we will do the cross multiplication. 3 into 3 will be equal to 2 into 3 plus W. 3 into 3 is 9, will be equal to 2 3s are 6 plus 2W. 9 minus 6, after that 2W will be equal to 9 minus 6, that is 3. And finally you can say W equals 3 by 2, which is actually 1.5. Got it? Also you can,
So should I, is it alright if I keep it till 3 upon 2
yeah, that is also
and
fine.
not convert it?
This is also fine. No problem. No problem with this. Yeah. Next, you have to find what is X. Again, the same. That is, this 2 upon 3 will be equal to X upon X plus 2. After this, we will do the cross multiplication. 2 into X plus 2 will be equal to 3X. Then 2X plus 4 will be equal to 3X. This 2X goes on that side. 4 will be equal to 3X minus 2X. Therefore, 3X minus 2X is X, and that is X equals to 4. Got it? Is that clear? The next is, yeah, let's do the question number that is 11. First tell me which two triangles are similar. First tell me which two triangles are similar. Sing, man. Alright. Fine. You can take these two triangles. Now over here, if I take in this triangle, if I take only this part, and in this triangle, if I take the whole triangle, okay, can I say that this right angle is equal to this right angle?
Yes.
Yeah. Also, this angle is equal to this angle for both the triangles. Now, if two angles are equal, what I can say that the two triangles are similar, but the sequence should be proper. What sequence it should be? If I say triangle WYZ is similar to which triangle?
Triangle dot WXY.
What?
WXZ.
WXZ. Wrong. Why? Because if I say WXZ, angle W is not equal to angle W. Because over here, angle W is something like this. And over here, angle W is 90 degree. So that's why it is wrong.
Uh, YWZ.
YWZ. Then it will be the same triangle. I want triangle name of this.
XWZ. XWZ.
Perfect. That is XWZ. Why? Because see, this angle Y and angle W both are 90 degree. You can see it. Angle Y is 90 degree in this triangle. And angle W is 90 in this triangle. They both are equal. Angle Z is common in this. So they both are also at the same position. Fine. Angle W and angle X. If these two angles are equal, this angle and this angle has to be equal because this is the third angle of the triangle. So the angle W and angle X are equal. So they are also at the same position. Therefore, this writing the triangle in this sequence is right. Got it? Now can you write the corresponding ratios and put the values and get the answers of X, Y, W, whatever you have. Can you get it? Write the corresponding ratios now, that is Wy upon Xw will be equal to Yz upon Wz will be equal to Wz upon Xz.
Um, I'm actually a little confused, so let me confirm. Wy over xw
Hmm.
equals to yz over wz
Hmm.
equals to wz over xy,
Perf. Xz.
correct?
It's Z.
Yeah.
Z.
Wz upon Xz. See what you have to do. Wy upon Xw. You can also write your answer in the chat box if you get it. Then Yz upon Wz will be equal to Wz upon Xz. Fine. What are the values of this? What is Wy?
So
Wy is 4. What is Xw? That is 5.
5.
5.
What is Yz? That is V.
V.
Wz. W. Again, what is Wz? Again, W.
W.
Uh, Wz, no? Yeah, W. Upon, the next is Xz. Xz is
Plus
3 plus V. Xz is 3 plus V. Fine.
so now we do the equation first.
Okay.
Two variables.
Yeah, there are two variables in both the
Extra.
cases. So we are not
Both
getting
the
the
cases.
values. Okay. So there will be some other thing then. What we can do in this question is we can already apply a Pythagoras theorem. That is, in triangle, WYZ, it's a right angle triangle. So can I say W square will be equal to 4 square plus V square? Yeah, I can say this.
Similarly with the bigger triangle.
Yeah.
So W square
Yeah,
plus
one more thing, one
5
more
square
thing,
will be
one
3
more thing.
plus.
Wait. To get this, we'll need one more thing. Wait, we'll not do it in this way. You will have to take one more triangle. Means if it is not coming in this way, then you have to do the other way. Now, what is the other way? The other way is, as we have proved that this triangle is similar to the whole triangle. Yeah. Similarly, if I take this small triangle and the whole triangle, in triangle W, Y, X and triangle W, Y, X and Z, W, X. Wait, we'll take that main triangle as the same. What was the main triangle in this? XWZ, no? Over here also I'll take the X triangle XWZ. Triangle XWZ will be in triangle XWZ and triangle XYW. In triangle XWZ and triangle XYW, what I know, angle XWZ is equals to angle XWZ is equals to angle XYW. Yes or no? Both are 90 degree. Yes or no? Both are 90 degree, no? Also, angle WXZ. This is XWZ, no? Yeah, WXZ is equal to angle YXW. Why? They both are common. They both are common angle for both the triangles. Therefore, if two angles are equal, then what I can say? Therefore, triangle XWZ is similar to triangle XYW. I can say this. Yeah. Now what we have proved initially, that this two triangle is also similar. These two triangles are also similar. So over here this and this are same, no? If this is similar to this and this is similar to this, then this both are also similar. Yeah, I can say that. Therefore, can I say if
So
this is your equation 1 and this is your equation 2, yes, Krish?
all the three triangles are similar.
Yes, all these three triangles will be similar. Therefore, triangle WYZ will be similar to triangle XYW. Now, if these two triangles are similar, what I can say? WY upon XY will be equal to YZ upon YW will be equal to WZ upon XW will be equal to XW. Fine. Now let us take the triangle. Yeah. Now you can see what is WY. WY is 4. What is XY? That is 3. What is YZ? That is V. What is YW? 4.
Four again.
What is WZ? That is W. And what is XW? That is 5. You can get the value of V and W now.
Yeah.
Yeah, now you can get it easily. So 4 upon 3 is equals to V upon 4. So this 4 goes on that side. V will be equal to 16 upon 3. Similarly, W will be equal to 5 goes on that side, 20 upon 3. Understood? Now the next. Now the next question. The photo shows a rectangular picture 16 centimeter 8 centimeter surrounded by borders of width 4 centimeter. Are the two rectangles similar? They will not be similar. The similarity is only in terms of triangle. It will not be in terms of rectangle. Even if the angles are equal, they cannot be said as similar. Why? Because see, if this is a rectangle and this is also a rectangle, can we say they both are same? They cannot be same because if I enlarge this, if I say, if I take this, if I say this is one of my figure, okay, and the other figure is like this, and if I enlarge it, this both are similar, right? This both are similar. But if I draw any other rectangle like this will be similar. This both are similar, yes or no? They won't be similar
No.
because a similarity is like if you enlarge it or if you reduce it, it should be congruent. Now I cannot enlarge this triangle in any way, or either it will reduce in any way that it will be purely congruent. That is never possible, no? Got it? Therefore, the two rectangles cannot be equal, cannot be similar if they are of 90-degree all. Okay? But if you have two squares, then if I say,
They are similar.
how? If I
All
say this is one,
squares, all, all sides of the square have 90 degrees. So
so what?
they are similar.
Because
They
So
are
if
not
you
similar because they won't overlap each other. They
pr-
won't be congruent if
if they have been
shrunk or
if yeah, if they have been resized. But see over here, I'll make it.
they
If
can
this
be
is a square, I can make it like this, no? Yeah, it will be of equal size. Now it can be
yeah,
overlapped. Yes or no? So a square can be overlapped if it is resized, but a rectangle cannot be overlapped if they are two different rectangles. Got it? So if two squares are there, they can see we can say that the two squares are similar. Any square is similar to any other square. All the squares are similar to each other. All the rhombus are similar to each other. All the parallelograms are similar to each other or not? What is parallelogram? First, you should know that. Do you know it or not?
it's a quadrilateral where the opposite sides are parallel.
Yes, you are right. It's a quadrilateral where opposite sides are parallel. Now let's leave it the parallelogram and all. First, what you need to understand, the rectangles cannot be similar even they are all of 90 degree, but all the squares are similar. So what is the question over here? Are the two rectangles similar? No, they are not similar. Next, the diagonals of a trapezium intersect at O. AB is parallel to DC. AB is this. Then find AO and DO. Fine. Let us do the question number 30. Over here, what they are saying, there is a trapezium. Now, how do we draw the trapezium? In the trapezium, what do we have? What is trapezium? How do we draw the trapezium?
AB and CO will be parallel lines.
Yeah, there will be two lines which will be parallel.
Yeah.
Okay, there will be two lines which will be parallel. So what I have to write?
Now the
I
longer
have to
line
write
will be
A,
6
B,
centimeter.
C, D. The naming is proper, yes or no?
Wrong. No, it's right.
It's right or wrong?
Wrong, because AB is parallel to DC, not CD. So D and C should be
Reversed.
interchanged.
Okay. It's not like AB is parallel to DC, then that does not define what you are saying, because whenever the diagram is not given and when you are writing ABCD and all, either it should be clockwise written or either it should be written anti-clockwise. It cannot be written in the zigzag manner, means A, B, C, D. You cannot write it like this. If you are starting A, then B, that C has to be over here only. Even if they give AB is parallel to DC or CD, whatever, even if they give or don't give. But when you are starting A and B, the C has to be over here and D has to be over here. You can also name it like this, CD.
Trapezium is regular, the one that you
Yeah,
have
but the
drawn.
problem is they said
Because here
AB is
we have
parallel to DC,
irregular.
no? So this sequence is not right. So it has to be in this sequence only.
No, sir, I was saying that the trapezium that you've drawn is regular, whereas the one in the question is irregular trapezium. That also remains.
Still did not understood what you are saying. Can you please repeat?
Over here, if you see the diagonals, one is 3 centimeter, one is 6 centimeter. So
Okay.
is it because it is a irregular trapezium?
AB and DC, irregular trapezium. AB and DC. Why? What is irregular trapezium? But there are two types of trapezium.
AB
One
should be
is
a bit smaller and
There are two types of
DC should be
trapezium.
bigger.
One is trapezium and one is isosceles trapezium. What is the difference between isosceles trapezium and a trapezium? You will be having two equal sides. Means if it is an isosceles trapezium, then this side will be equal to this side and this side will be parallel to this side. But if I say only trapezium, then this side will be parallel to this side. That's it, nothing else. Okay, and this side is equal to this side, it is not given. But yes, angle and this angle will be acute, and this angle and this angle will be obtuse. That condition is there to be a trapezium. Got it? Now over here, what they give, AB is 3, DC is 6, CO. Where is CO? We don't know. But AB's the diagonals of the trapezium intersect at O. So let's draw the diagonals also. Fine. CO is how much? 4. OB is if this is O and OB is 3, and then find AO and DO. This is what you need to find. How you'll find?
If this would have been an isosceles
What?
trapezium, if this trapezium could have been an isosceles one,
It's
so
not an
AO
isosceles.
would be 3
It's
and
not isosceles. It's not given, no? It's not isosceles.
AO would be 3.
How?
What's the same length?
Which same length? How you cannot
Um,
do the guesswork.
will uh, O will CO be equal to AO as vertically opposite
Yeah, these two angles are equal.
sides?
This angle is equal to this angle, yes. This angle is equal to this angle, yes. Also, I can say that this angle is equal to this angle. Why? How can I say that these two angles are equal? Can you tell me?
Alternate angles.
Exactly. Since these two lines are parallel and this say can be considered as a transverse, then these two angles are equal by alternate angles. So what I can do in triangle AOB and triangle AOB and COD. Fine. What I can say, angle BAO is equal to angle OCD. Why? Alternate angles. Okay. Also, this angle will be equal to this angle.
Sir,
Angle
so,
ABO will be equal to angle CDO.
sir,
Yeah.
sir, it's angle BAD.
BA. No, it is
That's
not BAD. It
D.
is BAO. BDABO. No, nothing is wrong. Which one? Which part you are saying wrong? First, second, third, fourth. Which one you are saying?
First.
BAO. That is right. It will be BAO. This angle is equal to this angle, no? OCD. Got it? Yes, no,
No,
Yes.
sir.
no. Perfect. Now, if the two angles are equal, then can I say that the two triangles are similar? Therefore, triangle AOB will be similar to triangle COD. You please mind the sequence, right? If I am writing AOB, it should be COD only. Why? Because this angle is equal to this angle is equal to this, and this angle is equal to this. Getting it? Yeah? So now if these two triangles are similar, then I can say that the corresponding sides are proportional. That is, AO upon CO will be equal to OB upon OD will be equal to AB upon CD. Now what I will do, I'll take the triangle. What is the value of AO? That I don't know. What is the value of CO? I know that 4. What is the value of OB? That is 3. What is the value of OD? That I don't know. What is the value of AB? That is 3. What is the value of CD? That is 6. So if I take this 2, I get the value of OD. If I take, yeah. So 3 upon OD,
Also in exam,
yeah.
do we need to draw the trapezium or we
You
have to
have
do
to
it in our
draw,
mind?
no, you have to draw the trapezium. You have to draw the trapezium because without drawing it, you will not be able to get it. You have to draw the trapezium. So this is 2 and this 2 comes on this side, OD goes on that side, 3 into 2 will be equal to OD and finally the value of OD equals 6 centimeter. Got it? This were in terms of centimeter, yeah. Also, you can equate this with equal to this.
Yes, sir.
Okay,
Yes.
fine. After this, I can say AO upon 4 is equals to 3 upon 6. This one gets cancelled. So AO will be equal to 4 upon 2. Finally, I can say the value of AO is 2 centimeter. Understood how to find the value of AO and OD? Is that clear completely? Yes or no? Please raise your hands if it's completely clear.
Yes, sir.
Pahal, okay. Vritti, okay. Krish, what about you?
Last.
Clear? Fine. The next problem. Next is a tree of height 4 meter cast a shadow of length 6.5. Find the height of a house casting a shadow of 26 meter. Can you solve this question in the homework? Now, the next. Can you try solving this question number 14? What they have given, a tree of height 4 meter cast a shadow of 6.5, then find the height of a house casting a shadow of 26 meter. Do you get it how we can solve this question? Yes or no?
No, sir.
No. Fine.
I will do 26 divided by 4 and then
But what is the reason
Okay.
of doing dividing and multiplying and all? You should be knowing, you should be telling me with proper reasons. Even if you tell the right answer, I want it with the proper reason.
tree of height 4 meter cast a shadow of 6.5
Yeah.
meters. So we need to find
See
the
over
height
here.
of 26
See over
meter
here.
now.
Suppose if this is your ground, okay? Suppose this green line is your ground, okay? And there is a tree, right? There is a tree like this, okay, which is 4 meter height. And it is casting a shadow of how much? 6.5 meter. That means it is giving this length of shadow, okay? So the shadow will come with respect to what? With respect to the sunlight, no? That means the sunlight is this inclined, right? That's why it is giving like this. The shadow will be this much. Fine. So similarly, if there is a house whose height is 26, which is giving a shadow of 26 meter, which is giving a shadow of 26 meter. So that height will also be the same, no? In the same inclination. Yes or no? They both will have same inclination because the sunlight is coming at the same from the same source, right? So this should be the height of the house. Yes or no? We know that all the objects which we construct on the road all are vertical. Yes or no? All are vertical. So this both are 90-degree.
Yes.
And the inclination will be same. The sunlight's inclination will be same. So this angle and this angle both will be same. So what I can say, if this is triangle ABC and this is triangle PQR, can I say that the two triangles are similar? Yeah. This shadow is 6.5 and this height of the tree is 4. This shadow is 26. We need to find what is the height of this house. What I can say, these two triangles are similar, then what I can say, AB upon PQ, see, triangle ABC will be similar to triangle PQR. So what I can say, that is AB upon PQ will be equal to BC upon QR will be equal to AC upon PR,
AC upon
right? So what all values I have? AB and BC. So the value of AB is 4, PQ is I don't know. The value of BC is 6.5 and the value of QR is 26. The
so you
value
can
of
write the
AC
value of
I don't
PQ
know
as
the
X.
what?
You can write the value of PQ as X.
Yeah, you can write PQ as X or you can keep it as PQ only, no problem. No, you will get ultimately the value of PQ. You can solve this equation. PQ goes on that side. 4 into 26 upon 6.5 will be equal to PQ. So finally, the value of PQ will be equal to 4 into 26 into 10 upon 65. Yeah. After this, what I can do? We'll cancel in the table of 5. 5 twos are 5 13s are 13 twos are 4 twos are 8 8 twos are 16. The value of PQ is 16. That means therefore the height of the house will be 16 meters. Got it? Is that clear?
Yes.
Yeah,
Yes, sir.
fine. The next problem which you have. Tell me which of them will be similar. Which of the following must be similar to each other? Two equilateral triangles will be similar or not?
Yes.
Yes, they will be similar. Two isosceles triangles will be similar, yes or no?
Yes.
Yes,
Yes, sir.
because the triangles are similar almost all the time. Because in the two isosceles triangle, wait, in the two isosceles triangle cannot be similar. It cannot be. Why? Why it cannot be similar? Can you tell?
because of the width of the triangle.
Because see, if I can say this is, can I say this is my isosceles triangle? Can I also say this is my isosceles triangle? These two triangles are similar? Yes or no? They both are not similar, no? That's why two isosceles triangle cannot be similar all the time. Two regular pentagons will be similar, yes or no?
Yeah, pentagons is similar.
How? Uh, can you tell Pehel? They will be similar, yes or no?
Yes.
See how we can draw the pentagon? Uh,
It's five sides, like
yeah, it's a five side polygon.
five
Yeah,
equal sides.
yeah, five sides polygon. It's like this. Yeah, it's a five side polygon. All the sides are equal in this case.
Equal.
Yeah. So if I enlarge it, this will be the two polygons.
Trapezium.
Now over here, this angle
Yeah,
will be same because it's a regular polygon, no? If they give you only two pentagons, will be similar, yes or no? If they don't give you regular over here, then what happens? They will be similar?
no, they are not.
No.
Then they won't be similar because when they mention regular, only at that time all the internal angles are equal. If they do not mention regular, that means all the angles can be anything. Because any polygon with five sides can be said as a pentagon. But when we say a regular pentagon, that means all the five sides are equal of the pentagon. Got it? So a regular pentagon, yes, they are similar. Two rectangles, no, as we have already discussed. Two squares, yes, all the squares are similar to all the other squares. Two kites, no, because kite can be of any shape. Yeah. Two circles, yes. Two rhombus, yes. No, not two rhombus. Why? Because the angle of inclination will differ, no? The inclination angle of a rhombus differs. See, if this is the rhombus, it is not possible because I'm unable to draw it in it properly. The two rhombus cannot be similar because one of the inclination can change, no? This inclination angle, if this is 110 degree in this, it can be of 120 degree also. The rhombus can be made of 120 degree also, and then the two rhombus will not be similar in that case. That's why all the rhombus will not be similar. Clear? All the squares will be similar because their angles will not
Can you
change.
draw? Can you draw a rhombus freehand?
Can you draw what?
Can you draw two rhombuses freehand?
Acha, which are not similar, like that.
Yeah, which are not
Okay,
similar.
okay, fine. See over here, I'll draw. This is the rhombus, and see, this is also the rhombus. These two rhombus are similar. They cannot be similar because even if I reduce the size of this or increase the size of this, even if I increase the size of this, it cannot overlap it. It cannot be overlapped.
Oh,
Are you getting it?
yeah.
Yeah. That's why two rhombus are not always similar, right? Because it depends on the inclination, no? That's why. Fine. Further, in this question number 16, what you have? In the diagram, angle ABC is equal to angle ADB is equals to 90 degree, and AD is equals to P, and DC is equals to Q. See, this is the same kind of question where this is 90 and this is 90. We have solved this type of question over here. It is the same kind of question. Please try solving this question as in your homework. Okay, you should get. Now,
Yes, sir.
yeah, the next. In a triangle ABC, a line drawn parallel to BC to meet AB and then form a rectangle ABCD. Fine. A square is cut off to leave a. Okay, fine. Just a moment. Fine, let us complete doing this question. I'll give you a rough explanation how we can solve this question. See, in this triangle ABC will be similar to triangle ABC will be similar to triangle BDC. Also, triangle ABC will be similar to triangle AD ABC will be similar to triangle ADB also. So finally, I can say these two triangles are similar. So triangle BDC will be similar to triangle ADB, and after that I can say corresponding ratios are equal. That is BD upon AD will be equal to DC upon DB will be equal to BC upon AB. Fine. After that, take this triangle. Take this triangle. Now over here, BD. BD is what? We don't know, but we can write in terms of, see, this is Y and this is Q. So this will be under root of, okay, you can use Pythagoras in this triangle. So this side can be, using Pythagoras, it can be written as Y square minus Q square. Also, this side can be written as, yeah, you can write it as Y square minus Q square. So BD is square root of Y square minus Q square. AD, AD is P. DC is Q. DB, again under root of Y square minus Q square, is equals to BC is Y, and AB is X. Fine. If I take these two equations, okay, what I get? Square root of Y square minus Q square upon P is equals to Q upon square root of Y square minus Q square. If I do the cross multiplication, if this both gets multiplied, square root and square root will get into Y square minus Q square will be equal to PQ. So this is what they have asked. Use similar triangles to show that x square equals pz. Fine, we will be proving it. Find a similar expression for y square. So a similar expression for y square will be pq plus q square. Y square will be equal to pq plus q square. This will be the expression for y square. Also, we have to prove x square equals pz. X square equals pz. How we can prove that? Yeah, for that we have to use these two triangles. Then we will be able to do it, because the x is the part of this triangle, that is triangle ABD, and z is the whole triangle. We'll do this question in the further class, in the next class also, and then we'll continue it. Okay? For the time, we can end this session over here. Okay? We'll continue this. How was the class? Did you understood everything which was taught before?
Yes, sir.
Yeah, sir.
Yeah?
Yeah,
Yeah,
sir.
sir.
Everything is
Yes,
clear,
sir.
no? Okay, okay. Fine then. We'll continue in the next class. Sure. Bye bye.
Hi, sir.
Yeah.
Thank you, sir.